I am just in Santa Barbara. Nishi was supposed to be here, but was unfortunately unable. So we are filling in for her, and I have been joined by the very capable Chen Pang from AWS and Nick Turner from AWS, and hopefully Team AWS will mostly be giving the update today. And I will basically give a quick introduction about, I think, mostly some mechanics, so some of the sort of what SIG stuff, which we'll see is not entirely accurate, and then we'll dig into some of the technical stuff. Nick, you're going to talk about the cloud provider, and
yes.
Chen is going to talk about CSI, and then we're going to share sort of our vision or wish list for 2020, but we're really, fingers crossed, going to leave a lot of time this time for Q&A, and really I want to hear about what you want to see in 2020 for AWS and Kubernetes. So my bit first is a hopefully fairly quick bit of administrivia, which is we are technically no longer SIG AWS. We are now Provider AWS. And hopefully this will be mostly about a simple string substitution, but it's a little bit more complicated than that, and I'll dig into why we did it and why it's a good thing. So I think the fundamental challenge that everything across all of Kubernetes is facing is how do we scale the project as it grows from what started off as a group of much less than 100 people building this thing to what is now a conference of 10,000+ people, and how do we scale that work out while at the same time making sure that everything is consistent, that when you use one API, it feels similar to using another API. When you're using it on AWS, it feels similar to GCE, all these different. So what we did is we changed SIG AWS so that it is now under the SIG Cloud Provider umbrella. It's no longer a SIG. And so what used to be all the SIG clouds are now provider clouds. And technically, they're no longer SIGs. They are sub-providers underneath SIG Cloud Provider. I think there are some really amazing things about SIG AWS that we wanted to carry forwards. And so the Slack, which has a wonderful community, is now Provider AWS instead of SIG AWS. And the mailing list or Google group is still Kubernetes SIG AWS because apparently that one's harder to rename. But if you're looking for the SIG AWS on Slack, it is now Provider AWS. And if you're looking, technically we are no longer a SIG. So I'm just going to do very quickly, like if you have a question or you want to know where, you knew where things were before, now where are things. Let's go through that quickly. So if you want to talk about something Kubernetes and AWS specific, still the great place, a great community to hang out in or ask initial questions is going to be Slack. And so Provider AWS is a great community space. I think a lot of people are in there. If you have more in-depth questions, Slack is probably not the best forum in general for those things. And for those, the mailing list is always a good option. If you found a bug or want to fix a bug or want to add a feature, technical decision making is done by the SIGs, as it always has been. And so SIG Cloud Provider, I see Walter, who is one of the leads, if not one of the leads of SIG Cloud Provider is here. So if it's a cloud provider thing, that's where that SIG or SIG network or SIG storage as appropriate. And again, the goal there is to make consistent decisions across the various platforms, so that a networking feels the same whatever cloud you're using. Bugs or suspected bugs go to GitHub as always. Ideally, the goal is they go against the correct project, and the goal is that bugs don't sort of sit in the KK repo and sort of get a little bit lost. But obviously, it can be very hard to know where a bug is, and like figuring out where a bug lies is almost half the work. And so it's okay to guess and put it in KK if you don't know, but I would personally guess first and allow it to be rerouted rather than putting it into KK. But if you genuinely don't know, then KK is a fine place. And PRs, hopefully you know where your code lives, the code that you're changing lives, and so those do go to the relevant project. And if you're not clear on where that code should live, then discussing with the SIG who presumably own the code is the right way to establish that routing. And the goal there is that contributions are easier than they have historically been in Kubernetes. So I hope that makes sense to everyone. So now if you're wondering, where did my Slack channel go and why is it provider AWS and not SIG AWS, that is what we changed and why it was changed. All right, Nick, tell us about the cloud provider.
Okay. Please. Testing. All right. So the cloud provider sort of encompasses all of the cloud provider specific code in Kubernetes. And some of the recent developments in that space has been around essentially removing it all from Kubernetes core. There's a couple reasons for that. One of them is just the bloat. All of the SDKs bring in a significant amount of code bloat. Another reason is that this makes it a lot easier if we have an interface rather than getting cloud provider PRs merged into core. If we have some sort of an interface and the cloud provider bits are separate, it makes it a lot easier for cloud providers to have their own release track. They don't have to wait for Kubernetes releases. If they have a bug fix going out, they don't have to wait for that to go out. So that overall, I think it's a really good thing. So again, migration out of tree, basically what I just said. And there's a KEP about this, removing entry providers if you're interested in looking at that in more detail. So one big piece of this migration is the Kube Controller Manager. So if you're not familiar with the Kube Controller Manager, it is a binary that is part of the Kubernetes control plane, which has a number of controllers running, basically control loops running inside of it. Some of these control loops have nothing to do with anything cloud related. Others have a lot of cloud provider code inside of them. So part of this process of breaking this out of tree involves separating the Kube Controller Manager into two pieces, what we call the Kube Controller Manager and the Cloud Controller Manager. And this presents some difficulties. If you're operating a Kubernetes cluster in an HA manner and you don't want any downtime, then you have the issue when you have a Kube Controller Manager running of the old version, and then you want to upgrade to the new version where you've actually split these apart. You might have the cloud control loops conflicting because so the approach here is essentially to create a migration lock so that the leaders in the old Kube Controller Manager basically don't conflict with the leader in the Cloud Controller Manager. So that makes the migration process significantly easier and hopefully with no downtime. Let's see, so here's just sort of an example where you see, for example, if we were doing 117 migration, you have the core controllers and the cloud controllers all in one binary in the Kube Controller Manager. And in this example, we've actually already broken out some of the cloud controllers into the Cloud Controller Manager. And this set of network cloud controllers is to be broken out. So the first step is to point those controllers at this migration lock. And then the next step is to actually migrate them over to the Cloud Controller Manager. So the tentative timeline for this, and these are very subject to change, but this is just sort of our high-level goal for next year, specific to the AWS external Cloud Controller Manager. We're looking at kind of a 0.1 version in 2019. And then come 2020, we'd like to have alpha at the beginning of the year, beta sometime around May, early summer, and then a GA closer to August, fall. That is very subject to change, and it also depends on how the actual migration machinery goes in core. So don't hold me to those dates. Cool. Any questions about that? If not, we can move on to CSI.
Very cool. So my name is Chen. I'm coming from Amazon EKS. I'm working on CSI drivers most of the time. Today I'm going to give some updates about the CSI drivers development we have been made since last KubeCon. All right, so since last year, I remember the first release was 0.1 since last KubeCon in 2018. Since then, we've already had several iterations. Now the latest release is 0.4. It's already been declared as a beta stage. Since then, we have been implementing several extra features. The first one's CSI raw block volume, where you can actually declare a device as a raw block and get it mounted into the container. So that it's going to be useful for some applications like MySQL if you're super wanted to have the high performance. You don't want it to go through the actual layer of file system. This might be an option for you, and it is beta since version 1.14. Second one is a CSI volume expansion, where you can expand the EBS volumes in real time, and it's going to be resized to the new size whenever you update the PVC capacity size, and has been beta since 1.16. And the next one is volume snapshot, so by which you can create a snapshot by given EBS volume, and also you can restore new EBS or persistent volume claim by which EBS volume has been created from a snapshot which are given. And that feature is, as far as I've seen, is supposed to be being beta for 1.17. So another extra thing we added is a new file system for the XFS. We're already supporting the ext2, ext4, ext3. So this is one extra one we have been adding incrementally. And the last one but not least is the CSI migration. If you know, the CSI is a new initiative. It's trying to be the new model of developing this out-of-tree driver for the storage use case. Just because there's already EBS in-tree plugins being written, and there's a migration problem has to be solved in the Kubernetes community, by which this quarter we are already, I think the latest PR got merged to make it flip to beta, but to be careful about this is it's going to be beta off, so this migration flag is going to be two flags basically. One flag is going to be called CSI migration, which is going to say you're going to turn on this migration. Where it's going to be a separate flag, which is storage plugin specific, like in the case of AWS, there's going to be a flag called CSI migration AWS, where it is being beta, but by default it's off. So if you want to turn it on, you need to turn it on explicitly. So other than those features, there are several like nice improvements. One of them is the Helm chart and customize. You can start using them to install the drivers. So for the next step, CSI just released a new spec, 1.2, where the driver now is still being developed against a 1.1 spec, and the next step is definitely keeping it up. And also we're planning for the J plan, several of the items, including bug fixes and more testings, end-to-end testing, as well as benchmarking the performance of the driver. All right, so next one is EFS CSI driver. It's got donated to the Kubernetes SIG since the beginning of the year. By the time I was at version 0.1, since then it's had one iteration. It's been declared as like the latest release is 0.2. The features being implemented so far including static provisioning, where you can bring in a pre-provisioned EFS file system and you put in the file system ID in a persistent volume. And then the driver will take care of mounting the volume inside of your containers. And also you can specify extra mount options. Like one of the unique things for EFS is you can say, you can enable the encryption in transit where you're going to specify this TLS mount option. where all the traffic between your container and to the EFS backend are encrypted. And also, we added more end-to-end test cases. The thing to highlight here is that test cases are actually using the upstream SIG storage testing suite, which including a bunch of test cases, including like static provisioning and with different cases. And also, as being compatible with the EKS IAM for service account feature, which just been launched in EKS since a month or two ago, where you can actually just, the original way of, say, authorizing this container into the AWS, you need to give the worker node the IAM role, but which sometimes is like not secure enough. You want to really strip down the scope where you can use this feature. Next step, definitely like a Helm chart, more configurability, and also dynamic provisioning. One thing we're thinking about this is because EFS is a little bit special, we are expecting the way it's being used. Feel free to give us your feedbacks. It's like the EFS is really being created over and over again. But instead, it's more of user, whenever it's an application being deployed, you're really looking for creating a new directory within a given EFS file system. That's where we're like foreseeing this dynamic provisioning going to work. And the next one is provisioning the EFS file system. Although like most of the time you don't want this, but just in case you want a Kubernetes native experience, right, like to provision this EFS file system, just because it's highly configurable, you can say you want to create a EFS in various availability zones with different security groups, and how to configure them in a Kubernetes native way. We're thinking of using the AWS Service Operator framework to achieve this. And also, the last one is the FSX for Lustre CSI driver. FSX for Lustre is a high-performance parallel file system. It's being optimized for machine learning workload or HPC workload. It has been donated since the beginning of the year still. Had several releases. The recent one is 0.2. Has static provisioning, which if you're familiar with this storage, you already know, like also dynamic provisioning, where you can create a Lustre file system on demand, which we think this is handy for this use case. Is FS for Lustre is usually used for like a data caching solution, where you can cache some data from your S3. Like you might have a terabytes of data lives inside your S3 bucket, but you might not want to download all of them into your file system so that you can start processing them. For FS for Lustre, it provides a handy feature where you're lazy loading those data only when they're being accessed. And also mount option, you can specify the flock. Similar thing as IAM for service account. Next step is adding more end-to-end test cases, which I already mentioned. One of them is using the upstream test suites. CSI 1.2 and Helm chart and customize. So if there's any questions, otherwise I can just go to the demo. All right. So the demo is going to talk about the simple workflow about how this EBS CSI migration works. So at the beginning, take a look at the pods. You see there's CSI driver being installed. And there are 2 controller servers, and there are 2 node services where I'm running a 3-node cluster. Then this is the demo YAML I'm using. If you look at, there are only pretty simple 3 sections. The first one is storage class. It is exactly the same as the current in-tree EBS storage class. The part to highlight here is the provisioner, as you can see as a Kubernetes.io/ebs/ebs, where we are used to use to provision EBS volume using the entry plugin. Now they are the same because we already turned on the migration feature. The second one is just, as usual, you declare a persistent volume claim. Here is like 4 GB. Then you create an application where it's just right into the provision volume. Then just apply the YAML. Like you can see, there are 3 API objects being created: storage class, PVC, and the apps itself. You can see first the PVC is already bounded, by which there's volume being created on demand. Then let's take a look at the persistent volume. And you can see like the storage class is the one we defined earlier. Then just watch on the pod. Sometimes it takes like several seconds to get it to be fully created and deployed and running. All right, so it's created, and you see like using kubectl exec, you can see the data is being written. All right, that's it.
Cool. Thank you, Jay. I think we have one last thing, which I think we were going to do a mini quick panel just to get everyone going and get some of the blood flowing, talking about what we want to see in what we hope to see in 2020. I think that's what we're talking about. I will kick us off, and I think you mentioned the IAM service account, IAM for service accounts, which I'm super excited about, and I would love to see that packaged as a cluster add-on. I'd love to see that so that it can be used everywhere across like EKS and COPS and kubeadm and cluster API clusters, and that it's all consistent, and that we also try to package all the other things we've talked about, Cloud Provider, the CSI drivers, that we maybe test them across all the various platforms so you have the same sort of experience, and to see that happening across all the clouds. I think that'd be awesome. I don't know if you guys want to. You're live.
So yeah, one thing that I'm interested in, we created a Helm charts repo for a couple of our app mesh add-ons. So I'm just kind of curious for user feedback, if people have used that, or if they like using Helm charts, if they want to see more of our various offerings in Helm charts, we'd be interested to know.
Cool.
Yeah. Awesome.
No? All right, let's throw open to the crowd.
I got one more. I'd also like to see, everyone who is either operating a Kubernetes cluster on AWS or just a user on AWS, I'd love to see more people at the SIG meetings, bringing issues forward. I think we're going to try to, partially on us, like I think it sort of has, attendance has declined a little bit recently, but I think we're going to try to step it up next year.
At the provider meetings.
Sorry. Excuse me.
Yes.
Provider meetings, yeah.
That'd be good.
And
we could make it more of a formal user group, I think, might be the new
Yeah,
thing.
so there is talk of user groups. We're not really sure what those are yet, but we might turn it into a user group.
We might be the first.
We might, yeah. See what happens.
All right, let's
open it up.
Yeah. Do you want to shout and I'll repeat if need be? Or I don't see any roaming mics, do you?
No, I'm not sure.
Where are we actually going in terms of this? Like, you get Kubernetes out of the box. Where are we going to stand for AWS? Like, you're going to have a cloud provider component now, and it's going to be like, what do we get out of the box?
So to repeat the question,
Yeah.
The question is, what do we get out of the box in this new 2020-21 world when cloud provider is external, CSI is external, these things are external? What do we get out of the box?
So I think one thing is that's sort of up to whoever's packaging Kubernetes for you. So how are you installing Kubernetes, right? If you're using a managed service like EKS, then you don't really notice these changes for the most part. If you're installing it with, kubeadm or something like that, then I think all that's to be determined exactly how the migration would happen.
Yeah, I mean, I think that's why I'm excited or hopeful about cluster add-ons. If we can create so we're deliberately trying to put less into the core box, but then I'm hoping we can have these add-ons that nicely let you, in a repeatable fashion, whatever toolkit you're using, whether you're rolling your own, whether you're using EKS, maybe, but certainly across the open source ecosystem, like we'll just be able to drop those pieces in, so it will be hopefully a better experience than you have today, because although there are more pieces that you are dropping in, everyone is dropping in the same pieces. They're tested, they are released in a more modular fashion, so you don't have to wait for the next release.
Yeah, and so
we can have, like, let's just get the IAM in there. Let's get all the load balancers, everything put in there. So you have one Helm chart, you throw it, you cast it through, everything's up running. Not just looking at it just from the stories, or just get a lot in there. Because right now, like, the whole situation with IAM just feels messy. Particularly both authenticating into the cluster and the containers themselves accessing IAM.
yeah, I agree with that.
Yeah, and that is what we're trying to figure out in different areas, but also in like cluster add-ons is where I think a lot of this is happening, and
Definitely.
it would be a big YAML file, for example, with a bunch of descriptions of the things you want to install that are nicely modularized, and the ones you put in there are the ones you get, and there would be a YAML file you fork for, like, that's a pretty basic starting point, and you could also have a more advanced starting point.
Yeah. So like the EKS specific approach to this is not yet defined, but I think one thing we're thinking about is using Helm charts to make this a lot easier, and then maybe there will be some kind of a managed add-ons solution in the future. I'm not sure if I'm correct about that. Maybe Vipul can comment. But, yeah.
One of our biggest needs right now is to distribute traffic amongst 2 or 3 Kubernetes clusters.
Mm-hmm.
Is there any plans to be able to spawn like an NLB that can be trafficked to more than just one cluster?
I mean,
NLBs in front of NLBs?
I can't speak to NLBs specifically, but I know that that's one of the near-term goals of our app mesh add-ons for clusters. So giving services between clusters connectivity is one of the primary reasons that someone would set up app mesh, essentially.
And I'd also say that's the sort of thing which SIG multi-cluster is trying to collect use cases on. So if you have these use cases, that would be, they are sort of wondering what the most important use cases are, and it sounds like you have a specific use case in mind. So.
Well, I think
Yeah.
in general, NLB is something that several people have been asking for, to be able to have autoscale groups and be able to distribute traffic between those 2 autoscale groups, for example. So it'd be nice if there was some kind of product offering. We've heard we're working on it, but we haven't seen anything.
Okay.
Yeah, I have no idea about that, so sorry.
I think we're a little over time. Should we do one more question of you? I know you had your hand up, and then we'll break out for.
Yeah, and we can continue asking questions or answering questions at the time.
Roadmap for service operator on Kubernetes. And use
Yeah.
cases.
I'm not the best person to answer this, but I can.
I can answer this. In RFC, they're working on the design for version 2, and there are a lot of design issues open on the GitHub repo, and they're asking for feedback, use case, and what do you want to do.
And so there's an RFC out. Just to repeat, there's an RFC open on the GitHub repo, and the GitHub repo is github.com.
Yeah, I think it is.
AWS Labs, AWS
Service
Service Operator. Probably.
So it's
Thank
a great time, if you have ideas, it's a great time to give feedback.
All right. Let's call time and have some discussions
Sure.
after.
Sounds good.
Thank you so much.
Thanks, everyone.